Everyone, our project is a home alarm system built with a Raspberry Pi Pico. We wanted to create an affordable home security solution that does not require internet or subscriptions. The idea is that if a motion is detected, the system turns on an alarm with a flashing LED, a loud buzzer siren, and a warning message on the LCD.
The alarm can only be turned off with 3-button password. We are using a PIR motion sensor, LED, buzzer, 3 push buttons, and an LCD screen, all controlled by Pico running our Python code.
Hello, my name is MZ Kamal and I worked on the buttons component.
My name is Tony Wong. I work on the LED and motion sensor.
My name is Abdurrahman Shoair and I worked on the LCD screen.
Hello everyone, I'm Micah Fernandez and I worked on the buzzer component.
First, I will show you the motion sensor right here and the LED. So right now, the system is idle. This LED says system ready, and the LED is off. So when I move my hand in front of the PIR sensor, it outputs the value of 1, and our code sets alarm on to true. That turns on the LED and changes the LED to arm motion so the user knows something triggered it.
Similar to the LED, once the PIR sensor is triggered, the buzzer will turn on.
The LCD is connected over I2C on pins GP0 and GP1. At the start, we scan for the I2C address, make an I2C LCD object, and then we use the code lcd.put_string to print messages. We use the LCD screen to show the current state of the system.
To turn off the alarm, you have to enter the correct 3-button password. Here are passwords red, blue, yellow. There, it's off.
Basic flow of my part starts in LCD displaying system ready. Alarm on set to false, and it reads the PIR value. If the PIR value equals to 1 and the alarm on is false, we set the alarm on to true. Turn the LED on and change the LCD to alarm motion.
The role of the buzzer was to serve as an audio alarm output. The algorithm starts as the buzzer waits for a motion detection signal from the PIR sensor. When motion is then detected, it immediately activates and stays on in a continuous fashion. The buzzer then monitors the password verification status from the buttons. With this, the buzzer only turns off once the correct password is entered. The buzzer connects to a GPIO pin and uses simple digital high and low stats to control sound output.
The LCD component begins by clearing the screen and displaying system ready. Once motion is detected, it will display alarm motion. Afterwards, upon every button press, the color correlating with that button will display so the user sees what they entered. If the password is correct, it will demonstrate that the password is successful and go back to system ready. However, if the password is wrong, the LCD will show wrong password and then try again.
The button component handles password input and disarming the system. The algorithm monitors button presses, storing each input in a set of variables. After each press, it compares the entered sequence against the pre-programmed correct password. If there's a match, it sets the verification to true, which turns off the buzzer, LEDs, and LCD. If incorrect, it waits for a new attempt. Furthermore, the set of buttons only accept input when the alarm is active.
Later.